Hello everyone, this is your course instructor Monisha KH, Assistant Professor, Department of EC, Sai Vidya Institute of Technology. In this lecture video, we'll be continuing with Module 3 of Information Theory and Coding, that is Information Channels. In this lecture video, we'll be studying about mutual information and its properties. So first, before going to the properties, we'll know what is a mutual information. On an average, we require h of x bits of information to specify one input symbol. However, if we are allowed to observe the output symbols produced by that input, we require then only h of x by y bits of information to specify the input symbol. Accordingly, we come to the conclusion that on average, observation of a single output provides with h of x minus h of x by y bits of information. This difference is called as mutual information of the channel, denoted by I of x comma y, given as I of x comma y equal to h of x minus h of x by y, as shown in the figure 2. Next is, notice that in spite of variations in the source probabilities P of xk, that is, maybe due to the noise in the channel, certain probabilistic information regarding the state of the input is available once the conditional probability P of xk by yj is computed at the receiver end. The difference between the initial uncertainty of the source symbol xk, that is log of 1 by P of xk, and final uncertainty about the same source symbol xk after receiving yj, that is log of 1 by P of xk by yj, is the information gained through the channel. This difference we call as mutual information between the symbol xk and yj. Thus, I of x comma xk comma yj equal to log of 1 by p of xk minus log of 1 by p of by yj. This can also be written as log of p of xk by yj by p of xk, or I of xk comma yj equal to log of p of xk comma yj by p of xk into p of yj, since p of xj comma yk equal to p of xj by yk into p of yk. This is about mutual information. Next, we'll be moving on to the properties of mutual information. The first property is the mutual information of a channel is symmetric. That is, I of x comma y equal to I of y comma x, where mutual information I of x comma y is a measure of uncertainty about the channel input that is resolved by observing the channel output, and the mutual information I of y comma x is a measure of the uncertainty about the channel output that is resolved by sending the channel input. To prove this property, we first use the formula for entropy. That is, h of x equal to summation j equal to 0 to j minus 1 p of xj into log of 1 by p of xj to the base 2. This can also be written as h of x equal to summation j equal to 0 to j minus 1 into p of xj into log of 1 by p of xj to the base 2 into summation k equal to 0 to k minus 1 p of yk by xj. Next is, by simplifying the above equation, that is summation j equal to 0 to j minus 1 into summation k equal to 0 to k minus 1 p of yk by xj into p of xj into log of 1 by p of xj to the base 2. Further simplifying this equation, that is p of yk by xj into p of xj can be written as p of xj comma yk. So substituting that in the equation, we get it as summation j equal to 0 to j minus 1 into k equal to 0 to k minus 1 p of xj comma yk into log of 1 by p of xj to the base 2. Next, this is because, as I told, p of xj comma yk equal to p of yk by xj into p of xj. Substituting h of x by y equal to summation k equal to 0 to k minus 1 into summation j equal to 0 to j minus 1 P of xj comma yk into log of 1 by P of xj by yk and equation 4. That is what we've got in the previous slide. In equation 1, we get I of x comma y as summation j equal to 0 to j minus 1 into summation k equal to 0 to k minus 1 p of xj comma yk into log of p of xj by yk by p of xj. Next, we have something known as base theorem. So P of xj by yk by P of xj equal to P of yk by xj by P of yk. So substituting equation 6, that is the base theorem equation in equation 5, what we have got, we get an equation, and arranging the summation terms, we get an equation for I of x comma y, that is summation k equal to 0 to k minus 1 into summation j equal to 0 to j minus 1 p of xj comma yk into log of p of yk by xj by p of yk. This is nothing but I of y comma k. Hence, we have proved that I of x comma y equal to I of y comma x. This is about property 1. Next is property 2. What is property 2 tells us? The mutual information is always non-negative. That is, I of x comma y is greater than or equal to 0. To prove this equation or property, we first note that P of xj by yk equal to P of xj comma yk by P of yk. Hence, substituting 7 in equation 5, what we've got in property 1 derivation, we may express the mutual information of the channel as equation 5 is this one, that is I of x comma y equal to summation j equal to 0 to j minus 1 into summation k equal to 0 to k minus 1 p of xj comma yk into log of p of xj by yk by p of xj. Substituting in this equation, we get the equation as, for mutual information, I of x comma y equal to summation j equal to 0 to j minus 1 into summation k equal to 0 to k minus 1 p of xj comma yk into log of p of xj comma yk by p of xj into p of yk. Next, to prove this equation or derive this equation, a direct application of the fundamental inequality. There is a concept known as fundamental inequality in ITC. So using that concept, we yield the desired equation. That is I of x comma y greater than or equal to 0. With equality if and only if P of xj comma yk equal to P of xj into P of yk for all j and k. Hence, property 2 states that we cannot lose information on the average by observing the output of a channel. Moreover, the average information is 0 if and only if the input and the output symbols of the channel are statistically independent. This is about property 2. Next is property 3. What does property 3 tell us? The mutual information of a channel may be expressed in terms of the entropy of the channel output as I of x comma y equal to h of y minus h of y by x, where h of y by x is a conditional probability. This is what is property 3. There is no proof for property 3. The last one is property 4. Property 4 states that the mutual information of a channel is related to the joint entropy of the channel input and channel output and is given by I of x comma y equal to h of x plus h of y minus h of x comma y, where the joint probability, that is h of x comma y, is defined by h of x comma y equal to summation j equal to 0 to j minus 1 into summation k equal to 0 to k minus 1 p of xj comma yk into log of 1 by p of xj comma yk. From the equation 8, what we have seen, or to prove that equation, we need to rewrite the definition of joint probability, that is h of x comma y as h of x comma y. We will be splitting the above equation as summation j equal to 0 to j minus 1 into summation k equal to 0 to k minus 1 p of xj comma yk into log of p of xj into p of yk by p of xj comma yk less summation j equal to 0 to j minus 1 into summation k equal to 0 to k minus 1 P of xj comma yk into log of 1 by P of xj into P of yk. This is equation 9. The first double summation term on the right hand side of the equation 9 is recognized as the negative of the mutual information of the channel I of x comma 5. As for the second summation term, we manipulate it as follows. That is summation j equal to 0 to summation k equal to 0 to k minus 1 P of xj comma yk into log of 1 by P of xj into P of yk. That will be equal to summation j equal to 0 to j minus 1 into log of 1 by P of xj into summation k equal to 0 to k minus 1 P of xj comma yk plus summation k equal to 0 to k minus 1 into log of 1 by P of yk into summation j equal to j minus 1 into P of xj comma yk. We are just splitting this equation, writing it separately. That's it. If you multiply the summations again, it will be, you'll get the same equation. We are splitting this equation, writing it in the form of this equation. Then further using these equations, that is P of yk equal to summation j equal to 0 to j minus 1 P of yk by xj into P of xj and P of xj equal to summation k equal to 0 to k minus 1 into P of xj by yk into P of yk. Using these equations, we can further simplify this equation as summation j equal to 0 to j minus 1 P of xj into log of 1 by P of xj to the base 2 plus summation k equal to 0 to k minus 1 P of yk into log of 1 by P of yk to the base 2. This is nothing but h of x plus h of y. So that we number it as equation 10. Accordingly, using equation 11 and equation 10 in equation 9. That is, this is equation 10, this is equation 9, and so substituting these two equations, we get an equation known as h of x comma y equal to minus I of x comma y plus h of x plus h of y. Rearranging the above equation, that is taking the minus term to the left hand side and taking h of x minus y to the right hand side, we get it as I of x comma y equal to h of x plus h of y minus h of x comma y. Hence, property 4 has been proved. This is about mutual information and its properties. Thank you.